Imagine a world without instant communication, a world where every message, every piece of news, and every important update had to be physically carried from one place to another, a world where news traveled at the speed of a horse-drawn carriage. Picture the anticipation and anxiety as people waited for weeks, sometimes even months, to hear from loved ones or receive critical information. Where sending a message across the country took weeks, if not months. The journey was fraught with uncertainties, bad weather, rough terrains, and the ever-present risk of bandits. This was the reality before the telegraph. Communication was a slow, arduous process that required patience and resilience. The invention of the telegraph in the 19th century revolutionized communication, shrinking distances and connecting people like never before. Suddenly, the world felt smaller, more connected. Before the telegraph, messages could only travel as fast as a person could carry them. This meant that the speed of communication was limited by human and animal endurance. This meant that communication over long distances was slow and unreliable. People often had to wait in frustration, not knowing when or if their messages would arrive. The telegraph changed all that. It introduced a new era where messages could be sent almost instantaneously, transforming the very fabric of society. It allowed people to send messages across continents in a matter of minutes. This newfound speed and efficiency had a profound impact on every aspect of life. The telegraph was more than just a new invention, it was a revolution. It fundamentally altered how people interacted, conducted business, and even how wars were fought. It transformed the way we communicate, do business, and even wage war. Businesses could now operate more efficiently, governments could coordinate more effectively, and military strategies could be executed with unprecedented precision. This essay will explore the key inventions and individuals that made this communication revolution possible. We will delve into the lives of the inventors who dared to dream of a connected world. From the initial experiments with electricity to the development of wireless telegraphy, the journey of the telegraph is a tale of innovation and perseverance. We will trace the evolution of this groundbreaking technology and its profound impact on 19th century society. The telegraph not only changed how we communicate, but also paved the way for future technological advancements, setting the stage for the modern world of instant communication we enjoy today. The story of the telegraph begins not with wires and dots, but with frogs and sparks. It's a tale that takes us back to the late 18th century, where the curiosity of scientists began to unravel the mysteries of electricity. This journey starts with an unexpected protagonist, the humble frog. In the late 18th century, Italian scientist Luigi Galvani made a startling discovery. While conducting experiments on frogs, he noticed something peculiar. Galvani observed that the legs of a dead frog would twitch when touched by two different metals. This was not just a random occurrence, but a phenomenon that would ignite a new field of scientific inquiry. He observed that the legs of a dead frog would twitch when touched by two different metals. This seemingly simple observation was profound. It suggested that there was some kind of invisible force at play, something that could cause movement, even in lifeless tissue. This force, as Galvani would come to believe, was a form of electricity. This seemingly simple observation sparked a wave of scientific inquiry into the nature of electricity. Scientists across Europe were intrigued. What was this mysterious force? How could it be harnessed? Galvani's experiments opened the door to a new understanding of the natural world, one that would eventually lead to the development of modern electrical technology. Galvani's work caught the attention of his fellow countryman, Alessandro Volta. Volta was a physicist with a keen interest in electricity. He was fascinated by Galvani's findings, but had his own ideas about what was happening. Volta believed that the electricity observed by Galvani originated not from the frog itself, but from the contact between the two different metals. Volta believed that the electricity observed by Galvani originated not from the frog itself, but from the contact between the two different metals. To test his theory, Volta conducted a series of experiments. He hypothesized that the metals were creating an electrical current when they came into contact with the moist tissue of the frog. To prove his theory, he built the first electric battery, known as the Voltaic pile. This was a groundbreaking invention. The Voltaic pile consisted of a stack of alternating zinc and copper discs, separated by pieces of cloth soaked in brine. When assembled, this stack produced a steady electric current. Volta's invention, a stack of alternating zinc and copper discs separated by brine-soaked cloth, provided scientists with a reliable source of electric current. This was a monumental achievement. For the first time, scientists had a consistent and controllable source of electricity. This opened up new possibilities for experimentation and discovery. This breakthrough marked a pivotal moment in the history of electricity, paving the way for future inventors to harness its power for communication. The Voltaic pile was more than just a scientific curiosity. It was a tool that would enable the next generation of inventors to explore the potential of electricity in new and exciting ways. The ability to generate and control electricity laid the groundwork for the development of the telegraph. The telegraph was a revolutionary device that allowed for the transmission of information over long distances using electrical signals. This was a direct result of the foundational work done by Galvani and Volta. Scientists and inventors now had the tools they needed to explore the potential of electricity for transmitting information over long distances. The telegraph would go on to transform communication, making it possible to send messages across continents in a matter of minutes. This was just the beginning of the electrical revolution, a journey that started with the twitch of a frog's leg and led to the interconnected world we live in today. While the invention of the battery provided the means to generate electricity, it was the discovery of electromagnetism that made the telegraph possible. The battery, invented by Alessandro Volta in 1800, was a groundbreaking development that allowed for a steady flow of electric current. However, it was the understanding of how electricity and magnetism interacted that truly opened the door to new technological advancements. In the 1820s, Danish scientist Hans Christian Ørsted noticed that a compass needle deflected from magnetic north when an electric current passed through a nearby wire. This was a pivotal moment in the history of science, as it was the first time anyone had observed a direct connection between electricity and magnetism. Ørsted's experiment was simple yet profound, involving a basic setup with a wire and a compass, but its implications were far-reaching. This observation, linking electricity and magnetism, intrigued scientists worldwide, including American physicist Joseph Henry. Henry, a professor at Princeton University, was particularly fascinated by the potential applications of this discovery. He saw the possibility of harnessing this relationship to create new devices and technologies that could revolutionize communication and industry. Henry built upon Ørsted's work and discovered that by coiling insulated wire around an iron core and passing an electric current through it, he could create a powerful electromagnet. This was a significant advancement because it allowed for the creation of magnets that were far stronger than any natural magnets available at the time. Henry's electromagnets could be turned on and off with the flow of electricity, making them incredibly versatile. Henry's electromagnet was far stronger than any magnet known before, capable of lifting heavy weights. This demonstrated the practical potential of electromagnets in various applications, from industrial machinery to scientific instruments. The ability to lift heavy objects with an electromagnet was a clear indication of the power and utility of this new technology. He also found that by rapidly switching the electric current on and off, he could make the electromagnet attract and release a metal lever, creating a clicking sound. This discovery was crucial because it provided a way to convert electrical signals into mechanical movement, which could then be used to transmit information. The clicking sound was the basis for the development of Morse code, a system of dots and dashes that could be used to send messages over long distances. This discovery would prove crucial for the development of the telegraph. The telegraph was one of the first technologies to use electricity for communication, and it relied heavily on the principles of electromagnetism. By using electromagnets to create signals that could be transmitted over wires, the telegraph allowed for near-instantaneous communication across vast distances. Henry's experiments with electromagnetism demonstrated its potential for long-distance communication. He showed that it was possible to send electrical signals over long distances and use them to control mechanical devices. This was a revolutionary idea at the time, as it opened up new possibilities for communication and control that had never been imagined before. The ability to control a mechanical device at a distance using electricity formed the foundation for the telegraph. This technology would go on to transform the world, making it possible to send messages quickly and efficiently across continents and oceans. The telegraph was the precursor to many modern communication technologies, and its development was a direct result of the groundbreaking work done by scientists like Joseph Henry and Hans Christian Ørsted.